Şunu şöyle yapayım mı? Biraz fazla aydınlık oluyor gibi. Okay. X0 being the point 1, 0, sending an integer, and to the homotopy class of the loop Wn, which is given by the following rule. Wn of S is just cosine 2 pi and S sine 2 pi and S based at x0 is an isomorphism. In particular, the fundamental group of the circle is isomorphic to the group of integers, infinite cyclic group, okay? And proof will be as follows. Okay, so let me first draw a picture. So this is the point x0, and this is the interval 0 to n. And you see that we divide this interval into, let's say, n in subintervals. Say this is I over n, this is I plus 1 over n. And from the expression of the loop, you see that each subinterval is just mapped to a whole circle, right? Because here I have 2 pi and S, therefore at pi over n, S equals pi over n, and I plus 1 over n, we are at this point. So each interval is just is mapped to the circle. Therefore, Wn just goes around the circle counterclockwise n times, okay? So this is a map from the integers into the fundamental group of the circle based at the point x0 and sends n to the homotopy class of the loop at x0. Okay, as I said, previously, there is no simple proof of this, okay? We have to go over almost the whole theory of covering spaces to prove this. There are some other proofs, but if you actually compare them, you see that the arguments just, shuffled, but they are almost the same. So you cannot just avoid the difficulties in the proof. That's why we will do it in a systematic way, so that we will use these ideas to actually study covering spaces also. So this proof actually is not just the proof of this, but it will actually tell us a lot of things about the theory of covering spaces, okay? Now, proof has several steps. First one is now consider the covering projection map. We have discussed this map previously. So this is the covering projection from the set of real numbers to the circle. And it is just this one, cosine 2 pi s sine 2 pi s. So what does this? This sends every interval of length 1 to the circle, right? So it's like this, 0, 1, 2, and so on. And then we have, so this thing is just mapped to the circle. And every interval of length 1 is just mapped to the circle, and it goes around the circle, once counterclockwise, every interval of length 1. Okay. Now, consider the following map, W and tilde. So remember, this was Wn of S. Now we have W and tilde. It is defined from real numbers into S1. Sorry. It's complete. From the interval 0, 1 into real line. This is not a loop, but it is just a path given like this, n times s. So what it does, it just sends the interval 0, 1 to the interval 0, n, right? So we have something like this. The interval 0, 1 is mapped to S1 via Wn, and here we have the real line, and we have the projection P, and we have this map W and tilde, and this diagram is commutative, right? Note that Wn of S is nothing but P of, so this is just cosine 2 pi n s, sine 2 pi n s. I can just regard it as follows. This is just P of, so in this P, instead of S, I have n times n s. So n times s is just W and s. So this is just P of W and S. So that this diagram is commutative. Okay. Daha açık yazayım mı? Şöyle yapayım isterseniz. Okay. Efendim? Şöyle yapayım. Bir daha şunu açıkça yazayım. Okay, now W and S. By definition, this is cosine 2 pi and S, sine 2 pi and S, right? Here is the definition of W and S. P is this function, and W is this function. So here, instead of S, I just write an S, and that is just P of, yani isterseniz şöyle yazayım. This is cosine 2 pi W n tilde of S sine 2 pi W n tilde of S, but this is just P of W n tilde of S. Therefore, we have this equality, right? Okay, now let's move to the other board. Okay. All right. Note that this function, the homotopic class of Wn, can be defined as the homotopic class of the loop P composition F tilde for any path F tilde in R from 0 to n, because any such F tilde is homotopic to W n tilde, keeping the endpoints fixed. Now let me explain this. We will use this kind of phrases a lot. So what we are doing is this. Here I have the interval 0, 1, and we have the circle, and we have here R. We have T here, and here I have W n. Here we have W n tilde, and suppose I have another map, okay, another map F tilde. Now, W n tilde just goes linearly from 0 to n, right? W n tilde goes from 0 to n, as S goes from 0 to 1, because W n tilde is just n times S. What about this F tilde? F tilde is any map, okay, any map, mapping 0, 1 to 0, n. So F tilde can be anything you want. Say, it can be something like this. It will start from this point. It can just go, back and forward several times, but it will end at this point. So F tilde is a map satisfying this. 0 is mapped to 0, and 1 is mapped to n. It's a continuous path from 0 to n, but it can do anything in between. Tamam mı? What we claim is that this function and this function are homotopic, keeping the base points, keeping the endpoints fixed. So what we claim is this: if you consider this homotopy, oh, I am sorry. Yeah. If you write like this, it's not a function, right? Same thing is mapped to different things. Okay, so F is, let's say, this homotopy. So picturally, it is this one. It will be, so this endpoint will be mapped to 0. This endpoint will be mapped to n. Here I will have w and tilde, and here I will have f tilde. Okay, so it's a homotopy from this function to this function. At this endpoint, it is always 0, and at this point, it is always 1. How can you write this map? Well, FST, R'nin kendisi konveks olduğu için bunu yazmak kolay. 1 eksi T W n tilde S plus T F tilde S. This function is clearly continuous, right? This is a real number. This is another real number. You just take a combination of this. So you get a function here, and it satisfies all these conditions. Let's check. F0, S0. So when t is 0, it is just W and tilde of S. Fs1, so when t is 1, this time this is 0. So you get just F tilde of S. What about the endpoints? 0 t, 0 t. When S is 0, so it is 1 minus t times W and 0, and here t F0. But both this guy and this guy are just 0, right? Because of the, this is just defined to be that way, and W and S is this, so when S is 0, it is 0. Since both of them are 0, this is just 0, and f of 1t is just 1 minus t W and tilde 1 plus t times f tilde 1. But this time, this is n and this is n. So 1 minus t times n plus t times n. Of course, this is just n. Okay, so it's a homotopy from W and tilde to f tilde, keeping the endpoints fixed. In other words, at any time, so this is the t-axis, this is the s-axis, your path starts from 0 and ends at n. Tamam mı? Şimdi şey yaparsak, bu homotopi, so what we see is then I have two different paths from 0, 1 to real line, and they're homotopic via some homotopy F, right? There's a homotopy from this one to this one. Well, I can just compose this homotopy by P, and I will get homotopic paths to S1. Okay. Do we need what? Mm-hmm. No, I am not claiming anything like that. I will just claim that this was WN, right? So what I'm claiming is that the element in the fundamental group represented by this and by this are the same. That's what I'm claiming. So this means what? I can just replace this WN by any other path, just starting from 0, ending at n. But it doesn't have to be the linear map from 0 to n, okay? It can be anything. So that's what I'm claiming. Now, WN is just P composition, WN tilde. And then we have some other path, let's say F. I am defining F. F is just P position, F tilde. And I know that these two are homotopic. So if I compose that homotopy by P, then, you know, WN and F are homotopic via P composition F. Now let's see why this is true. Yani tabii bariz olacak ama. First of all, this gadget, we know that this defines a loop, right? It starts and ends at the point. So WN is a loop starting and ending at this point. The composition P with F tilde is also a loop, right? It is little f. What is this? This is just P composition F tilde. Why is that? Because F tilde starts at this point and ends at this point, but both of them are just mapped to the point 1, 0. Therefore, this composition is a loop at this point. It starts from here, goes like this a little bit, maybe comes back, goes a little bit, and so on, but it will end at this point. So here, first of all, this F tilde, not F tilde, F is a loop at x0, which is 1, 0. Why is that? Because f of 0 is just p of f tilde of 0, but f tilde of 0 is just 0. So p of 0 is just 1, 0, which is x0. And f of 1 is just p of f tilde of 1. And f tilde of 1 is just n. And this is again just 1, 0, which is x0. So it's a loop at x0. And F composition P this time is a homotopy, from Wn to F. Why is that? Well, P composition F at S0 is just, what is this? This is just P of Fs0, but Fs0 was, Fs0, nerede o? S0, it was Wn tilde of S, and this is just Wn of S. P composition F S1, this is P of Fs1. P of Fs1 was Fs1 was F tilde of S, but this composition is called F of S. And we can check also the endpoints. We can also check the endpoints. P composition F, S, not S, 0T is just T of F0T, but F0T is 0T. F0T is 0. So this is just 0, and this is just X0. And P composition F1T is just P of F1T, and F1T is just N, right? Therefore, this is again X0. Therefore, we have this. So here I have P composition F, here I have Wn, here we have F, this is X0, and this is X0. Okay, so it's a homotopy from Wn to F. Therefore, the class of Wn is the same as the class of F in pi 1, S1, X0. And that was our claim, right? That was our claim. We just said that the class of Wn can be defined as the homotopy class of any composition like this, where F tilde is any path in R from 0 to N. Okay? Yani illa lineer gitmesi gerekmez. Sıfırdan başlayıp N'de biten her path lineer path'e homotopik. R'nin içinde. Evet. Şimdi yani dolayısıyla bu homotopi bize esneklik sağlıyor, değil mi? O homotopi klası represent eden bir sürü başka temsilci veriyor. Yani sıfırdan başlayıp n'de biten aslında her fonksiyon size bir şey veriyor. Representative. Okay. Alright. So o birinci adımdı. İyi demiştik değil mi ona? İyi demiştik. Bu 2'yi. So claim is this function is a group homomorphism. Okay. Our final aim is to show that this is an isomorphism, but first we need to show that it's a homomorphism, of course, because it's not clear. Okay, now şöyle diyeyim. Yani şunu göstermemiz lazım. We need to show what? Must show phi m plus n is this path times this path. So the homotopy class of m, this path is the product of this homotopy class of these two paths. Not composition, but the product of paths. Remember, so this was defined to be the homotopy class of this, right? This is defined to be the homotopy class of this. And then this is defined to be homotopy class of this. And this is the product in the fundamental group. Neydi o da? İşte bir peti diğerinin ucuna ekliyorsunuz. Değil mi? İki tane peti gidiyorsunuz birim zamanda. Yani homotopi petlerin kompozisyonu. Peki şimdi bunu şöyle yapabiliriz. Now WMS is just P of WM tilde S, and this is just P of MS. What is the product of W and W M in the fundamental group? Neydi bu? Zamanın yarısında işte bunu, diğer yarısında bunu gideceğim. Yani this is W, ilk önce bunu gideceğim. WN, değil mi? Öyle yapıyorduk. İlk önce bunu gidiyoruz. WN 2S and WM 2S minus 1. So this is in the first half, 0 to 1 over 2, and this is in the second half, 1 over 2 to 1. Okay. Well, this is the same thing as, okay, let me write it this way. So instead of this, I can just write P of 2SM, and this is P of, değil mi? Yani burada W yerine işte bunu yazabilirim. P of, okay. Efendim? Ha, ne olacak? Özür dilerim. Şurası da şey olacak. P of 2S minus 1 M. Değil mi? Okay. S 1 bölü 2 ile 1 arasındayken. Şimdi şunu yapacağız. Şöyle bir aslında yes. Well, the thing is that both of them are integers. So when you plug 1 over 2, you get 2n. When you plug 1 over 2, you get 0. But since they are both integers, p of any integer is just x0. That's why it is still continuous. Okay, now, so we have, let me draw a picture like this. So let's say this is the interval 0, 1, and this is 1 over 2. Here I have W n, and then here I have Wm. And here we have okay, just şöyle yani aslında ona gerek yok da şöyle diyeyim. Here it is n, here n plus n. So this thing is just mapped here, and this thing is just mapped actually 0 to m. So, but the thing is this: fs plus k for any integer is the same as ps plus k is the same as this, right? Because p is the trigonometric function, and if you add k, you get the same thing. Therefore, you know, the image of this piece is yani onun görüntüsü çarpımda nereye gidiyor? Sıfırdan m'ye gidiyor. So this is mapped to, this interval is mapped to 0 to n, and this is mapped to pardon, bunlar değil de bunların şeyleri aslında. Okay. Yok. Sonradan tabii P ile iniyorum. Şöyle düşünmek lazım. Wn dediğimiz şey şu. Wn is you map here this half interval into 0n, and then you just compose by p, and then this interval is mapped 0 to m, and then composed by p. But you see, instead of mapping 1 over 2 to 1 to 0 to m, I can just map it to n to m plus m. So yani belki şöyle çizeyim onu. So this thing here is mapped to here, but when I take composition with p, actually I can just shift this function by n and extend it here. So here I can just put n here. Therefore, the sum of the homotopy classes of Wn and Wm, yani şöyle diyeyim. So let me first write down what I mean and then I will explain. Yeah. Yeah, but actually what I mean by Wn, I mean the whole map. So I am taking also this composition. So this map is Wn and Wm. Okay. Şöyle düşünün. Now this is this composition is what? This composition, this map, this loop is represented by a path starting at 0 and ending at n plus n. What about this one? First I apply this. Yok. Şöyle yazacağım. N and m. First I apply this. So this is represented by a path starting at 0, ending at n in R. And then you add to this one, this gadget, and this one starts from 0 and ends at m. But the path starting at 0 and ending at m, and the path starting at n and ending at m plus n under the composition of with p, when composed with p, are the same. Therefore, this product also is represented by a path starting at 0 and ending at n plus n. Yani her ikisi de both this one and this product are represented in R by a path starting and ending, starting at 0 and ending at n plus n. Yani ne diyoruz? Bu klas sıfırdan başlayıp m artı n'de biten bir pet'in sınıfı. Zaten by definition öyle. Peki bunu nasıl görebilirim? Bu da sıfırdan başlayıp n'de biten, ondan sonra da sıfırdan başlayıp m'de biten pet'lerin product'ıyla veriliyor. Ama onları P ile kompoz edeceğim. P ile kompoz ederken de sıfırdan m'ye kadar olan pet'i n'den m artı n'ye kadar düşünebilirim. Dolayısıyla şu nesneyi sıfırdan m artı n'ye kadar giden bir pet'in P ile composition'ı gibi düşünüyorum. O zaman da her ikisi de şey olacak. Hani yani aslında belki şey diye mi söylemek lazım? Daha açıkça yazmak gerekirse buna karşılık gelen W n plus n tilde var. S bu n plus n S. Şuna karşılık gelen nesne de W n tilde ile W m tildanın product'ı gibi olacak. Yani W m tilde product W n tilde. Bunun S'teki değeri. Bu da nedir? W m tilde to S W n tilde 2s minus 1. S from 0 to 1 over 2, S from 1 over 2 to 1. This one just goes from 0 to n plus n linearly, right? What about this one? This goes from 0 to m. Evet, W 0 to m linearly. Ondan sonra da bu da evet, 0 to n'e kadar gidiyor ama şöyle yapıyorum. Bu nesnenin kendisi continuous değil. Right? This thing is not continuous because at 1 over 2 this is m and this is 0. But what you do is this. I will take composition of this by P, right? So when you take composition by P, you do the following. You just add here M. Yani buna eklersem so this gadget doesn't change because P just doesn't see this M here. But now it becomes continuous. And this shows what? This shows that the product is represented by a path from 0 up to n plus n. Same as this one. Therefore, this product is equal to this gadget. Yani şöyle görmek lazım. Bu nesne sıfırdan m artı n'ye lineer giden fonksiyonun p ile kompozisyonu. Bu ise sıfırdan m'ye kadar giden pet ile sıfırdan n'ye kadar giden petin kompozisyonu. Aslında yani şuralara tilde yazdığınız zaman bu product tanımlı değil. Neden değil? Çünkü bunun bittiği yerde bu başlamıyor. Değil mi? Bu n'de bitiyor. Önce n'yi mi gidiyorduk? Evet. N'de bitiyor. Bu ise sıfırda başlıyor. Ama şöyle yaparsam benim derdim bunların yani tildalar yok. Dolayısıyla eğer tilde gibi düşüneceksem bunları P ile kompoz edeceğim. P ile kompoz ettiğim zaman uç noktaların hepsi x0'a gidiyor ve şöyle de yapabilirim. Ben şu fonksiyona m eklediğimi düşüneyim. Evet, onları karıştırdım galiba, değil mi? Ya şurada şunu karıştırmışım galiba. Şöyle yapacağız. Okay. And here we will add n. So, evet, bu hani sıfırdan n'e, ondan sonra da sıfırdan m'e kadar giden iki tane pet var. Onları burada ucuca bile ekleyemiyorum ama buna n eklersem o zaman ucuca eklemiş oluyorum ve P altındaki görüntüleri değişmiyor. O yüzden de bu ikisini yani şununla şunu ne eklediğim zaman ucuca eklemiş gibi olabilirim, görebilirim. O zaman da bu sıfırdan M artı N'ye giden herhangi bir pet oluyor. Dolayısıyla da bunun sınıfıyla aynı şeyi represent ediyor. Süreyi doldurdum değil mi? İsterseniz bitireyim. Okey. Sorusu olan var mı?